Hi everyone, and welcome to today's Physics Daily Booster. This is number 5 in the series, and it is one of those advanced information listed topics. The topic we're going through today is the section 2.2 on the specification, so it is for higher tier folks. Obviously, that doesn't mean there won't be any questions on the foundation tier, because as we know, we've got that lovely little caveat that says there's a lot of stuff they're still going to examine anyway. What we're going to be looking at then is Newton's third law. Now, the very basics of this just tells us that for every action there is an equal and opposite reaction. So to all intents and purposes, what we have are pairs of forces. So what we've got within that interaction pair then is that these two forces are acting on different objects, but they're the same type, the same size, and they act in opposite directions. So we can see in the little picture of the apple down there, then what we actually have is we've got the force exerted by the earth on the apple, that's the downward arrow, and then the force exerted by the apple on the earth, the upward arrow. So they are in opposite directions, they're the same type of force, they're the same size, we can tell from the size of the arrows there, and they're acting on a different object, one on the earth, one on the apple. What we need to understand then are that we can categorize our forces as two different types, contact and non-contact forces. The non-contact forces, these are going to be the ones that occur because an object is in a field. So objects don't actually need to be in contact for the force to act. If we place something within a field, i.e. a region where there is some kind of thing like an electrical charge, a magnetic material, or a mass experiencing a force, then it will have a force exerted on it. There are 3 examples of non-contact forces you need to know. Just learn these ones: electrostatics, magnetism, gravity. So each of those are non-contact forces. Anything else they give you on the paper would be a contact force. So it can be a multiple choice question, obviously asking you to either identify one of the non-contact forces or even identify which is not a non-contact force. So know those 3. Basics on forces then, they are what we call vectors. And as we've already established in an earlier booster, a vector is something with a size and a direction. So magnitude and direction, or size and direction. So this is why we represent them by an arrow on our diagrams, because the arrow is allowing us to show the direction, and the size of the arrow allows us to show the actual magnitude or the size of the force. If we're asked to draw a force diagram for one of these non-contact forces, then we will start that arrow from the center of the object. Okay, so what we would have is our little object, there we go, a ball in this case, then the non-contact force would start from the center of it. Imagine that is a straight line. So of course, when we draw any of these on our exam paper, we would use a ruler to avoid the dodgy bent line that I've just created there. The other type, the contact forces, these are, as the name suggests, forces that only act when objects are in contact. Now, when we're drawing these on a diagram, we would always draw the arrow starting from the point of contact. I've given you 5 examples here: friction, drag, normal contact force, upthrust, and tension. So in terms of where we would see it, friction, that's going to be where we've got 2 objects in contact with each other. Generally speaking, this would be things like tyres potentially on a road, okay, so things that are moving against each other. Second one, drag. This would be, a lot of cases, things falling. So think about your typical divers off a diving board, skydivers they like here, could be a leaf or a feather, anything falling through the air, drag is going to be acting there. Normal contact force, this is one we generally forget. This is the force we get between basically the ground and something on the ground there. Okay, so this is the force that acts up against the object there. Upthrust, this is what we will find in things like water, so think boats on water at that point. And then finally tension, think about elastic type things. So bungee jumper is probably the best example of where they could use that one. If you're doing the higher tier paper, you need to know how to draw free body diagrams. Now, a free body diagram, quite simply, is just a simple diagram to show the forces that act on an object. Now, you don't have to be great at artwork here, because whatever the object is, we can replace it with either a dot or a box. So whatever it is, you don't have to draw that object as it looks in real life. Literally, just draw a dot or a box. So there are 3 steps to this. The first is we need to identify all the non-contact pairs. You don't have to write this down. If you can just do this in your head, absolutely fine. If you need to jot things down to help you with the process, do so. So we identify the non-contact pairs first of all. And if we look at the little picture below, we can see we've got a book and the earth there. So our first one is obviously the force of the earth on the book, pulling it down. And then the other is going to be the force of the book on the earth. So that's our non-contact force, because we're on Earth, we have gravity, therefore we have those 2. Step 2, identify the contact pairs. So in this case, because we've got a book sitting on a table, then we've got the force of the table on the book and the force of the book on the table. And then finally, what we need to do is focus on the single object. This will be what the question tells us. Now, in this case, we are looking at just the book. So the question would have said to draw a free body diagram for the book in whatever setting it was. And what we do, we don't draw a book. We can literally replace it with the dot. You see the black dot under part C there. So that is our object. We then need to just focus on the forces that were acting on the book. So the first one we've got is the force of the table on the book. So this one here, that becomes this force. We then need the force of the earth on the book from our first one, and this is our second arrow there. Notice how they both go from our little dot there, and they're in opposite directions. The arrows are the same size for the simple fact that the book is going nowhere, it's stationary. Therefore those force arrows must be the same size because the object is not moving. That brings us very nicely onto the idea of a resultant force. Now, quite simply, because forces are vectors, what we end up with if we're adding 2 or more forces together is the thing we refer to as the resultant force. So we've got 2 examples here. If we have a look at our first example, we have 5 newtons going to the left and 5 newtons going to the right. So in that case, we would have a resultant force of 0 newtons. Because they cancel each other out. 5 newtons to the left, 5 newtons to the right leads to a 0 resultant force. In our second example, we've got 3 newtons to the left, 5 newtons to the right. So that means if we look at the difference between them, it's 2 newtons. So obviously 5 minus 3 gives us 2 newtons, and that is to the right. So what we can do there is just work out the resultant force very easily, just by obviously subtracting. Now, they could, and I say could, ask you to do a trickier version of this, because it won't always just be the opposites that they're asking you to resolve here. Now, if you're looking to calculate the resultant force of 2 forces acting at 90 degrees to each other, then we're going to draw on our maths knowledge and Pythagoras. So remember, good old Pythagoras, then we've got our little right angle triangle. Obviously, if the forces are at 90 degrees to each other, then we can work it out because we've got A, B, C, okay? And hopefully we remember A squared plus B squared equals C squared. So you can just use Pythagoras to work out what force C actually is if they've given you the 2 at 90 degrees. So let's have a little look at an example question here then. Calculate the resultant force of a 2 Newton force and a 5 Newton force, acting at 90 degrees to each other. So as we read the question, as always, underline, highlight or circle the key bits of information so that we've got it to then refer back to nice and quickly. So what we're going to do is we're going to draw out our simple diagram to show the forces. So we've got a 2 Newton force and a 5 Newton force at 90 degrees to each other. So our little arrow here, A, is going to be our 2 Newton force. We've picked a scale and therefore we've stuck to it. In this case, 1 square is 1 Newton, as we can see. Then we've got our 5 Newton force along the bottom, and that is going to obviously be 5 squares long, which we can see in that little diagram. and then you just draw your line for C going from obviously the corner of B to the corner of A. Now we can then use good old Pythagoras to work this out, or you could even count the squares if you wanted, if it's on a bit of graph paper. This next question, I would say, is far less likely to come up for the simple fact that they don't insist on you taking a protractor into the exam. Now, if you don't have a protractor, this is going to be incredibly challenging to do because you need a protractor to do it. So I'm not actually going to dwell on this for very long. Obviously, if you want to know it in more detail, you can see the video on the main channel. But the basics are that we pick a scale, you then mark your start point, you measure that angle that they've given you. Obviously, it wouldn't be necessarily 90 degrees. In this case, it's 40 degrees. You then draw your lines to the correct sizes and make your right angle triangle. You can measure your lines to get the forces. But as I say, because they don't expect you to have a protractor, I highly doubt that's coming up. Final thing to do for today then is to head on over and have a go at the quiz to see how well you've understood today's work. Obviously, if there are bits you're not 100% certain on, the videos are on the main channel that you can go into a little bit more depth on them. Use your revision books, use your actual class notes, go through past papers and have a look at some previous exam questions on this topic. And don't forget to join us again tomorrow for our next Daily Booster.